Hello, everybody, and welcome back to Unit 2 of Regents Chemistry, which is Atomic Concepts. Today, we will be talking about the electron configuration, which is basically just how electrons are arranged in different orbits in an atom. So, first of all, let's just look at quickly how you guys can find where you guys can find the electron configuration in your reference table packet. So, if you turn to page 9 in your packet, where you have the periodic table, you'll notice that for each element that you're given, right in the very bottom left hand corner, you guys will find the electron configuration for that element. So the electron configuration for carbon is 2, 4. Now what this configuration is telling you is how many electrons are arranged in each orbit. So 2 basically just means you have 2 electrons in the first orbit, and then 4 indicates that you have 4 electrons in the second orbit. And overall, carbon has 2 orbits. And then remember that how do you know how many electrons does carbon has in total? Well, if this is a neutral atom, then the number of protons is equal to the number of electrons. So because the atomic number is 6, that should tell you that carbon is going to have 6 electrons when it is a neutral atom and not an ion. Now, what's the purpose of these electron configurations? Like, why are these electrons arranged the way they are? Or why do we write them in that form? Because if you guys remember the Bohr's model that we see in this picture, Bohr said that electrons revolve in energy levels or the orbits. Now, those orbits, each orbit has a fixed amount of energy associated with it. So they are also called the principal energy levels. This is also a very common word that you can see on the Regents. So do not confuse yourself. That's just the orbit or energy level. So what happens is that if we are looking at an energy level that is closer to the nucleus, then that is going to have less energy. If you're looking at an orbit or energy level that is farther away from the nucleus, then that is going to have more energy. So that's how this thing works. Okay, now if something has less energy, that means it can also occupy less electrons. And if an orbit has more energy, then that means it can occupy more electrons. So that's why these electrons are arranged the way they are. And all of these orbits have like a very specific capacity of electrons that they can hold. So remember that the electrons that will then be found in the lower energy levels, which means the energy levels that are closer to the nucleus, are going to have less energy. And the electrons that are going to be in higher energy levels, which means farther away from the nucleus, they are going to have very high energy. So this is the formula that we use to calculate that what is the maximum number of electrons that any orbit can hold. Now in this formula, the n represents the number of orbital that you're looking at, the number of orbit that you're looking at, excuse me. So for example, let's say we want to know how many electrons can the first energy level hold. So the n will be equal to 1 because we are looking at the first energy level. And all we have to do is just go ahead and plug in the 1 in place of n and do the math. So when we do that, 1 squared is going to be 1 times 2. That gives us 2, which means we can only fit 2 electrons in the first energy level. That's it. That's the maximum that it can hold. It cannot ever have 3 electrons. Then we move on to the second one. We do the same thing, plug in 2 in place of that n, and it gives us a 2 squared will be 4 times 2, that gives us 8. So the second energy level can hold a maximum of 8 electrons. Now, can it have less electrons than that? Absolutely. So if we are looking at an element that only has like 3 electrons, 2 of them are going to fit in the first one, and then the third one is going to go in the second one, and then that's it. That element doesn't have any more electrons to like fill in the orbit, so that's it. That's where we'll stop. And that is going to be the electron configuration 2-1. Okay, third energy level. Once again, we go ahead and plug in the numbers. So 3 squared is going to be 9. 9 times 2 is 18. Finally, do the same thing with the fourth energy level. Just plug in the numbers. 4 squared is 16 times 2. That gives us 32, which means the fourth energy level can fit in a maximum of 32 electrons. But of course, all of them can definitely have less electrons than this maximum limit, but they cannot have more than that. So this is what that looks like visually. So as you can see, we have the nucleus in the middle. The first shell can hold 2 electrons, the second shell can hold 8 electrons, and the third shell can hold a maximum of 18 electrons. So let's quickly practice writing the electron configuration, or more like finding the electron configuration from your periodic table. So if you guys turn to page 9 in your reference table packet, that's where we have the periodic table. And let's try to find the electron configuration for magnesium. That turns out to be 282. Remember, just look at the bottom left-hand corner, and that's where you find the electron configuration. That's where it is. At the bottom left-hand corner, the electron configuration is 282. Okay, next up we've got sulfur. We go to periodic table, find sulfur. The electron configuration, look at the bottom left corner, turns out to be 286. Next up we've got carbon. Find carbon in the periodic table. Look at the bottom left corner, electron configuration turns out to be 24. Now what these electron configuration means is that, so if you talk about magnesium, then 282 means magnesium has a total of 3 orbits. First orbit has 2 electrons, second orbit has 8 electrons, third orbit has 2 electrons. Sulfur, we have sulfur has a total of 3 orbits. First orbit has 2 electrons, second orbit has 8 electrons, third orbit has 6 electrons. Same thing with carbon. Finally, let's talk about zinc. Find zinc in the periodic table. Here we have the electron configuration 28182, which means the zinc has 4 orbits or energy levels. First orbit has 2 electrons, second orbit has 8 electrons, third orbit has 18 electrons, and then the fourth orbit has 2 electrons as well. Alrighty, so that is how you can find the electron configuration using your reference table or periodic table. Uh, I will see you guys in the next one where we'll talk more about the electron configurations.